Hello, what do you call it when one cow spies on another? It's called a stakeout. Ah. Okay, so now we're actually going to get into the graphing component. We're actually going to learn how to graph. And the most easy place, I'd say, to start is to actually start drawing straight lines, or in other words, linear graphs. Okay, whenever you see the word linear, I just want you to think it's a straight line. Okay, now straight lines, they have two forms. And I think this one's going to be a long lesson, so strap yourselves in. Straight lines have formulas in two main forms. The first form that you have is called the gradient-intercept form. Now, this gradient-intercept form is probably ideal. I'd probably say like 8 out of 10 times you'd want to be using this form, okay? Or 4 out of 5 if you're mathematically simplifying. So gradient-intercept form, that's what you want. It's best for sketching, finding the gradient and the y-intercept. The reason being is we've got this formula. Y is just part of the equation, but that m talks about your gradient, which is your steepness, or sometimes we call it our rise over run. Or if you remember, it was this formula, y2 minus y1 all over x2 minus x1, that thing. And then your plus c is your y-intercept, which is where it cuts the y-intercept. Now, we'll do some examples where you can actually see that in action, so don't stress. But just keep in mind, the gradient-intercept form, the key part here is it's a y equals. Y is the subject, okay? That's the important part. Gradient-intercept, you want y to be the subject. Okay, now, the other form that you have is this thing called the general form. Now, the easiest way to remember general form is it's whenever you see an equation that equals to 0. So if you see equals to 0, it is in general form. And what's good about this one is it's often easiest to leave this form this way. It's just nice. And also what you'll note here is it's no longer y equals, but now we've got all this stuff. We've got something that goes along with the x, that's your a. You've got something that goes along with the y, or a coefficient of y, which is in this case b. And then you're also going to have c, which is kind of like a constant. It's just doesn't involve an x, doesn't involve a y, and you'll see. So we'll have a go at this, but a, b, and c, they have to be whole numbers. They have to be integers. They cannot be fractions. They cannot be decimals. Okay, they can be positive and negative. That's fine. They just have to be whole numbers. Okay, integers. Now, to practice this, let's try rearrange this. So right now, this first one here, that's general form. Okay. The reason I know that's in general form is that equals 0. And now I want to write it in gradient-intercept form. And gradient-intercept form, if you remember, is the form where it starts with y equals. So in other words, all I'm really going to do is I'm going to try rearrange and make y my subject. Okay, so I can see here there's the minus 2y. I want to get the y on its own, and I'm noticing that it's a minus, so I don't want to deal with a minus y. This is just because I can see the trick. I'm going to move the y to the other side. Okay, so the way I'm going to do that is going to plus 2y to both sides. And you know what? I'm not going to do the in-between steps. I'm going to pray that you guys know what I'm doing. Because I'm plussing 2y to both sides, it disappears on the left-hand side. And I'm almost there. I've got my y on its own, but it's still got that 2. So what I'm going to do is I'm going to divide everything through by 2. And so if I divide everything by 2, 4x will divide by 2. That gives me 2x. And then also don't forget, every term needs to be divided by 2. So 10 divided by 2 is 5. And if you really wanted to, you could write it in this order. And the reason that I like the y on the left-hand side is now it looks like my y equals mx plus c form, right? Y equals mx plus c. So I can read here that, okay, my gradient is 2. and my y-intercept is 5, and we'll find that very, very helpful later on. Okay, that's changing from general form to gradient intercept. Now, often we'll ask you to do the other way around as well. So we'll write y equals 2x on 2 on 3x minus 1. So we can see this one here is in your gradient intercept form because it's y equals to m, x, and there's your c. Okay, so we can see it's in your gradient intercept form. What we're going to do is we're going to change it into our general form. So I want to make it equal to 0. Now, the first thing that I need to do is not only push everything to one side to make it equal 0, but I want to make sure that there are no fractions. So this here is a fraction. The way I'm going to undo that fraction is to multiply everything by that fraction. So my next line will look like this. 3y equals to, denominator cancels out, leaving me with just 2x. And then -1 times 3 gives me -3. And again, because I'm a little bit pedantic, I like whatever my x term is to be positive. So I'm just going to move everything else over. So I've got 2x. I'm going to minus the 3y over to get it to the opposite side of the equals. And I still have the -3 that never moved anywhere. It was just on this side. And again, the reason that I did it in this particular order is because now it looks like my ax plus by plus c. And then if I really wanted to, I'll put the equal 0 on the other side. So in this case, you can see that the a lines up with the 2. B would be -3, and c would also be -3. And you can kind of start matching your coefficients. That's what we call it. Okay, so that would be changing it into your, which form is it? General form. Okay. And again, you put it into that nice format so we can start to help ourselves out later when the questions need it. Okay, that's what we're doing. Hope that makes sense. Now, this is the part where it's going to get a little bit heavy. Now, stay with me here. We're going to, when we're trying to sketch any type of lines, whether it's a linear straight line or if it's a quadratic or a cubic or whatever else, there's these tools that we use that help us to sketch anything and everything. The most important one I'd probably say is the one that you use the most and is probably the easiest and the greatest value is finding x and y intercepts. Now, if I take a look at these, your x and y intercepts are simply where your graph will cut the x and y axes. So this one here will become our, that's an x-intercept, because that's where it cuts our x line, and then this is where it cuts the y. We're going to call that our y-intercept. Okay, now if you take a quick look, I'll do this in blue. The coordinates of these points are, this is the x equals -2, but the y value is 0. And for this one here, the x value is 0, but the y value is 5. So you can kind of see that for an x-intercept, your y value is always 0. And for a y-intercept, it's your x value that's always to 0. So the way that we will do this is to find the x-intercept. Let's write it in a color. Let y equal to 0. That's how we're going to solve it algebraically later. And for the y-intercept, guess what? We're going to let x equal to 0. Okay. So let's have an example here. We've got 2x minus 3y plus 1 equals to 0, and we're going to sketch it showing the x and y intercepts. So again, let's talk about the x-intercepts. The way we do that is we let y equal 0. So here I'm going to do that. I'm going to say 2x minus 3 lots of 0. So instead of y, I'm letting it equal 0, plus 1 equals to 0. And so here I've got 2x minus 3 times 0 is 0, plus 1 equals to 0, and then I'll get x equals to 2x equals to minus half. 2x equals to minus 1, x will equal to minus half. There's your x-intercept. So I'll look at minus half. There's going to be my x-intercept. Now let's do the same thing for the y-intercept. For the y-intercept, what do you let equal 0? You let your x equal to 0. So that means instead of going 2 times x, I would go 2 times 0. Take away 3 lots of y, which I don't know, plus 1 equals to 0. And here I can see that that'll be 0. That'll be minus 3y plus 1 equals to 0. And then solving here, I'm going to plus the 3y over to the other side, keep the positive 1 on the left-hand side, and then divide both sides by 3. So I can see that y should equal to positive 1/3. Okay, and it will be somewhat, let's say there, positive 1/3. And so if this is the line that we have, the way we would sketch it is, okay, approximately, that would be our graph, as long as I go through those 2 points. And that's how we would do it. So that's not a bad way to sketch all your straight lines. Find the x and the y intercepts by letting the appropriate coordinate equal 0, and then plot them down, draw a line through the two intercepts, right? The x-intercept is on the x line, the y-intercept is on the y-axis. Okay, x on the x-axis, y on the y-axis. Using the gradient-intercept form it tends to be quicker, but less accurate. So it depends. Now, when we talk about the word sketch, it just means, it doesn't mean the same thing as graph. Sketch just means showing main points, I guess. Main points / shape. So as long as it gives me a good idea, a sketch is great. Now for this one, I recognize that this is y equals to mx plus b form, okay? So if I recognize this is y equals mx plus, sorry, not b, we've been talking c. That means I know that the y-intercept is going to be -1. And I can see here that the gradient is going to equal to 2. Okay, so if my y-intercept is -1, I'm going to cut here at -1. And I can see here my gradient is 2. So to draw a line from that, I'm just going to draw a fairly steep line. As long as it goes through that point there, that would be my line. Same deal here. This time my gradient is 1/3. And my y-intercept is 3. So that means now I'm going to cut through 3. And I'm going to have still a positive 1, but less steep. So it may look a little bit more like this. Okay, next one. Now, what if I have a negative gradient and it's going to cut at -4? So I hope you're getting the idea here. That's your C. And this is your M. And so here my gradient is -½ It's going to be something like that, as long as I can draw a line that goes through another one. Okay, so that would be your line there. And that would be my sketch. And for this one here, you notice that it is not in your gradient intercept form. So I'm going to have to change it. So I'm going to keep my y positive because that's what I want. I'm going to minus the 4x to get it to the other side. And I'm going to minus another 3 to get it there. And so now I can kind of see, okay, my gradient is -4 and my y-intercept is -3. So again, I can see that that's going to be -3. And then a gradient of -4 will be fairly steep. As long as I go through there, that's going to be my sketch, and that should be good enough. Okay. Now, a little note on gradients. If I have a dead straight line here, this is y equals x, and this is a gradient of 1. Okay, maybe I'll do that in black, keep it consistent. Okay, now if I have something a bit steeper, and this is not perfect, it's not to scale, but the idea is if I have y equals 2x, that's a gradient of 2, and it's actually going to be a bit steeper. And if I go less, let's see how we go. So if I go less steep, this is y equals to, sometimes they'll say half x or x on 2, and your gradient is a half. So it's kind of less and less. And hopefully you can kind of see depending on where that is. And again, it'll work for this way as well. This one here would be y equals to -x. So your gradient here would be -1. And it works kind of the same all the way through. I'll use a different color now. If I've got a bit steeper, but it's negative, I'll still have y equals to negative 2x, and your gradient would be negative 2, it'll be steeper. But you can kind of see how the steeper it goes, the closer it gets to the vertical. And the closer to 0 it goes, kind of closer to the flat it goes. Okay. Now, unfortunately, we're not done. There's just a couple of special cases, and then we're done. Horizontal and vertical lines. Okay, now a horizontal line, we still consider that a function, and it's given by y equals. And if it's just y equals a number, it's going to give you a horizontal line. If it's x equals a number, that's going to give you a vertical line, and that's not going to pass the vertical line test. So we call that a relation. Okay, so let's take a go here. We're just going to sketch if y equals to 3. I'm going to find y equals to 3 on my, let's use a color. I'm going to use it on my y-axis, and then I'm just going to draw a line straight through. That's my line. If y equals to negative 2, then okay, maybe negative 2 is down here. And my line will just look a little bit like this. Nice horizontal. Now, if x equals to negative 2, then that means, okay, minus 2 will be somewhere here. That there would be your x equals to negative 2. And if I have x equals to 7, then, okay, let's say x equals to 7. That there would be my x equals to 7 line. Whoops, let's not translate. It will give me a nice vertical line. Okay, that was a long one. Hope you guys could keep up. If you need to, pause it and watch it again. That is it, and I'll catch you another time. All righty, bye-bye.